In this video, we are going to look at the graph of sine x and cos x, and for that we are taking help from the unit circle. And as you already know, the unit circle, and I already have the unit circle here with the circle with the radius 1, which is the unit circle. And we have, if it is a unit circle, then we can tell that this, the point here, it is 1 0. I already mentioned it's 1 0. This is 0 1, and that's a minus 1 0, and this is 0 minus 1. X 0 y is negative 1 in this point. So that's the unit circle, and we know that any point on that circle have the x and y coordinate, and the x coordinate is the cos theta and y coordinate is the sine theta. So basically, if we have at that point, and we know that the point is going, this is the horizontal distance and this is the vertical distance. So, and horizontal distance is x, which is cos theta, and the vertical distance is y, which is sine theta, for that coordinate x y, right? That's x y coordinate. X is cos theta, y is sine theta, and in that case r equal to 1, because r is the radius, which is the unit circle here. So it means when we are talking about the cos theta, so cos theta is basically talking about horizontal displacement. Am I right? So if I write down here, it should be horizontal displacement, right? Okay. And how about sine theta then? Sine theta will be the vertical displacement. Vertical displacement, right? Vertical displacement. And this is important because when we are plotting sine theta, we are looking for the vertical change. So when we are going from 0 degree, and this is 0 degree position because we are counting the angle from the x-axis, right? And then we are going anti-clockwise direction, right? So when we are going 0 degree position to 90 degree position, how much the vertical distance changing, and it is no vertical distance 0 degree. With increasing the theta, the vertical distance increasing, and it would be here maximum 1, then again going down when we are going more than 90 degree, right? So if you try to show that vertical distance, I mean for the sine graph, then how it would be looking like. So let's say we have the graph here, we have this is sine theta, so we can just write down even y equal to sine theta. This is our graph for sine. Okay, and let's say this is our 90 degree. Okay, 180, 270, and 360 degree. All right, and same way the minus 90, minus 180, 270, and 360. Right, so if I want to just draw up to that the range, the period, then what you are looking at here, the vertical distance will be 0 at 0 degrees. So we are getting a point here. If I just use the different color for the sine graph, this is 0 here. Another point you will give get when you are reaching 90 degree, you are going to, so this is basically 90 degree position. If I just quickly write down 90, 180, this is 270, and this is 360, right? Same way, negative 90, negative 180, and negative 270, and negative 360 degree. So when we are going for 90 degree, you know that you are getting a point which is maximum, which is 1. So we can say this is our 1, right? And then when you are going or above 90 degrees, it's again going down, the vertical distance will going down and is going down to 0. We are looking at the y coordinate, right? So these are the y coordinates we are interested in. Okay, that's the y coordinate. So now you can see it's coming to 0 at 180 degrees. So you are having another point here, right? And then another point will be 270 degree, it will be negative 1. So you can say at 270 you are getting negative 1 here, right? And then when you are reaching 360, then you are coming back to 0 position, so which is here. So now if you add these points, you are getting like that. So the points will be like that. So yeah, it would be a little bit sharp, and then you are adding the points here, and then going, we are adding like that. So it's a sine graph, right? And if you go to the negative direction, again you will come back. So it's again 90 will give you the maximum, right? So, but it's a negative 90. So negative 90 basically you are counting here, right? So it's again giving to negative 1, right? When you go to the negative 90, so it's a negative 1, right? Then 180 is give 0, then negative 270 is giving positive 1. This is negative 270 if you go to that direction. So positive 1, and then at sorry, 270 is here, positive 1, and then 360 will be 0, right? So this is not the point, so this is the point now. So if I extend it, it will be again like that. So I can just draw from this side, it's easy. So just going like that, and then okay, adding like that. That's the sine graph, right? You can extend more and more, but from here it's obvious that the graph is kind of repeating after, like, if you count from that point. So you can see that from that point to here, it is basically give you 360-degree, right? So that's 360 degrees is the period, because then after that the graph is just copying. So if you extend the graph, it will just cut and paste, right? So it's just copying. Like the negative side also you can see the same. So 90 is 0 degree to minus 360 degrees. So 360 degrees is the period. So here we know that our amplitude for that graph, I can write down here, amplitude will be 1, and then our period for that graph will be 360-degree, because every 360-degree the graph is repeating. That's called period, where the repetition started, right? Now, so this is our vertical movement we are observing for the sine graph. But when we are looking at the cos graph, then what will happen? Let's say we are trying to draw the cos graph here. So we are trying to make our angle the same position, so it's easy to follow here. Yep. So this is our, again, this is for this is our theta, and or in this case we are putting actually x. So it doesn't matter. So we are putting sine x here, and with the x is the angle, right? When we are doing, so this is if it's a theta, sine theta, cos theta, doesn't matter. Okay, so with changing the angle, we are getting the sine x. And when we are doing the cos theta or cos x, then y equal to cos x. But don't confuse with the y is not the coordinate y, is the function y equal to cos x. It's a y axis here, and here x axis will be the x, and that x is the angle, right? And now if you look at the cos, we have to look at the horizontal distance, because cos is talking about the horizontal distance, right? So as I said here, cos theta is the horizontal distance, and at 0 degree position your horizontal distance is maximum, which is 1. Okay, and here 90 degree position is 0, and then here cos is always x-axis, right? So I'm putting red color here now. So now you know that at 0 degree you are getting 1, so maximum, right? And then at 90 degree you are getting 0, and then at 180 degree you are getting -1, so that's it. And then 270 degree you are getting 0 again, so we are putting 0 here. And then at 360 degree you are getting again the maximum value, so which is because 0 degree you are reaching the 0 degree position at 360 degree position, right? And now if you expand it, then it would be like that. So like that, right? And now if I go to the negative direction, it will be like uh, so again, if you count that 90 degrees is 0 minus 90, and then 270 will be here. Okay, and then okay, so 90 degree, 180 degree. So it's a negative 180 degree, it's a -1, you can see it's a -1. And then again, when I am going negative, counting is again we are going to that direction. And negative 270 is 0, so that's 270 position. You are just looking at that, this is 270 position. And then we are going to 360 position, which is 1. So again, if you just do the graph here, That's reaching like that. And again you can see it's repeating. So if you start counting from that quarter, okay, then you can see you will get the same thing after 360. Then again you reach the maximum point. So that's the again start repeating after that. So it is 360 degrees. So I can say that period is in this case also period 360 degree, and amplitude again is a 1 here, right? Because that's the same thing. We have the coefficient of cos x is 1, so its amplitude is 1 in this case. Okay, so amplitude 1 and period 360, and that is graph for the sine x and cos x. And if you carefully observe that graph, two graph, that you can see um, they are basically 90-degree shift. So if you just plot these two graph in the same, or maybe I can just use the, I can just impose the blue one, the sine graph in here. You can see the graph is basically like that, right? So if I do like that, then it is coming down like that, right? And then it's going down like that, then it is going like that. So I'm just trying to show the that part, only the 0 degree to 360 degree, just to show how the graph is changing. You can see the graph is basically shift, right? If you just push the red one 90-degree forward, then it will impose to each other, right? So it's coincide to each other. That's why, or if you just push the sine to the 90-degree towards the left, then again it will coincide with the red one. So it means they're having 90-degree gap, so 90-degree difference, and it's uniform gap, right, everywhere. So everywhere is a 90-degree shift. So now we can say that that's why the sine and cosine, they are complementary angles. So sine theta and cos theta, they are complementary, and you can see that from the graph as well. Thanks. And also, some students, they might think why you are not connecting but straight. You can observe that even by putting two more points. So for both graph, if you just say, okay, how about sine 30 degree, for example, sine 30 degree we know is half. So if you go sine 30 degree, you can see that it will be somewhere here. It will give you sine half. So that is half, right? So that is half. So if I say what is sine 30 degree, you can see it will be like that, half. If I say what is sine of 60 degree, then you can see 60 degrees somewhere coming like that, right? So if I put a dot 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 here, and then put a dot 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 here, that is 60 degree, and that value will be 0 point, if I write down here, 0.866. If you put in calculator what is sine 60 degree, then you will see that it is coming 0.866. So actually sine 60 degree giving the point here, 30 degree giving a point here, and then you can connect. And same way you can check with the cos. Thanks for watching. Hope that will help. And if you'd like to see more up-to-date videos, please subscribe my channel.